Hello everyone, welcome back to my YouTube channel. I hope you all are doing well. Today I came here with the second part of data structures and algorithms video series, the linear data structures video. Okay, let's start.
Familiar, you're familiar. So if you don't know by now, then you should probably get familiar.
Okay, linear data structure is the fundamental concept in computer science, and these are backbone of the many algorithms and systems we use daily, from simple applications of our phones to complex databases. Come with me to the explore with how it works. This is my table of contents. Introduction to linear data structures, arrays, text, linked list, queues, short note of the linear data structure, and conclusion. Introduction to linear data structure. What is the linear data structure? Linear data structure is a type of data structure in which elements are arranged in a sequential order one after another. In linear data structures, each element has unique procedure and successor except for the first and last element. This makes it easy to traverse and access the element in a specific code. Linear data structures we can divide into four categories: arrays, stacks, linked lists, queues. Let's start with arrays. What is the array? An array is like a container that holds fixed number of elements all of the same type. Think of it as a row of blockers, each with the unique number. You can store anything you want inside as long as it fits the type, like integer, string, or even objects. This is the simple definition of the arrays. This is the simple example of the array. And this is the key characteristics of arrays: array length, first index, uh, first element, fifth element. Next up, we have stack. What is the stack? A stack is a bit like a stack of plates. You can only take the top plate off or add new one on top. This is the last in first out principle. This is the simple definition of the stack, and this is the simple example of the stack. Stack has three operations like push, pop, and peek. We can define a push as adding a plate to the stack. We can define as pop, removing the top of plate. Right? We can define as peek, just looking at the top plate without removing it. Stack are handy in scenarios like undo mechanisms in software, where the most recent action is undone pressed. Now let's talk about linked list. Unlike arrays, linked lists are most flexible because they don't require fixed size. They are like treasure hunt, where each clue points to the next clue. Each node has two parts, the data and the reference, or pointer to the next node. This is the simple definition of the linked list, and this is a simple example of linked list. Next, we move on to the type of linked list. You can see linked list has three types: single linked list, double linked list, and circle linked list. We can define as a single linked list, each node points to next. We can define as double linked list, nodes have pointers to both the next and previous node. We can define as a circular linked list, the last node points back to the first. Finally, we have queues. What is the queues? Think of queues as a line at a grocery store checkout. The first person in line is the first to be served. This is the first in, first out principle. This is the simple definition of the queue. A collection of elements with the first in, first out order. Elements are added to the rear and removed from the front. This is the simple example of the queue. Next we move on to the types of queues. Simple queue, circular queue, priority queue, DQ as the type of queues. We can define as a simple queue basic FIFO structure. This is the simple definition of the simple queue. Next we move on to the circular queue. The last position connects to back to the first saving space. Next we move on to the priority queue. Items are served based on priority. We move on to the DQ, double-ended queue where you can add or remove items from both ends. This is the simple definitions of the simple queue, circular queue, priority queue, and DQ. Next we move on to the short note of the linear data structure. Linear data structure, arrays, stacks, linked list, simply linked list, double linked list, and circular linked list. Queue, simple queue, circular queue, priority queue, and DQ. Next we move on to the conclusion. Understanding these structures helps us design efficient algorithms and systems, whether you are organizing your closet, managing a to-do list, or keeping track of train stations. Linear data structures are everywhere. This is the real-world example of linear data structures. Arrays, bookshelf, calendar, classroom, seating arrangement, stacks, undo functionality and software, plates in a cafeteria, browser history, linked list, train carriages, music playlists, to-do list, queues, ticketing system, printer queue, customer service calls. These real-world examples illustrate how data structures like arrays, stacks, linked lists, and queues are used to organizing and manage data efficiently in various scenarios. That's all for today's video. I hope you found this overview linear data structures helpful. If you did, don't forget to like, subscribe, and hit the notification bell so you don't miss any future videos. Let me know in the comments which data structure you find most interesting and why. Thanks for watching and see you next time. Bye bye.